Okay, so we have to find a power series representation for this function and also find the interval of convergence. So how do we do that? Well, we try to find something that we recognize in this. For me, I recognize the sum of a geometric series. So what was the geometric series? We had a initial term, and we had a common ratio taken to some exponent. And if you remember, the sum of this would give us something that looks very similar to this. It was a over 1 minus r. A, again, being the initial term, and r being the common ratio. So notice how that looks very similar, but yet it's not perfectly similar. We can't just say, oh, well, it looks similar, so 2 is a, and x is going to be r. We can't just go ahead and do that. We have to actually divide this by 3. Divide all the terms by 3 so that it looks actually like this. So we actually have 1 minus something, right, in that denominator. So we have 2 over 3 and 3 over 3 minus x over 3. So notice that when we do this, now we have it in the form that we want. Now it actually looks like that. Now it actually looks like that. And this would be our a now. So now we can make our back substitution into this and find our power series. This is 2/3. It's really this simple. It's really not complicated at all. And here you might think, oh, well, is it a negative? Is it a positive? Well, it's actually just the positive version. It's the positive because this is, you should view the minus as part of the structure of this formula, of this thing that we have here. Whereas what we're looking at is just the r itself, right? So this is x over 3, and we're taking this to the end. So what's the interval of convergence now? That was the other question. This is already what we found. This is the power series. It's really not that complicated. But the question now is, what is the interval of convergence? Well, where does this converge? Where does a geometric series converge? This is a geometric series, right? From 0 to infinity. It's a geometric series. And where does it converge? It converges where the absolute value of r is less than 1. That's just something that we had to remember. If you don't remember that in the test, tough luck, right? But that is actually the interval of convergence, and we know our r, which is x over 3. And you also need to know how to work with absolute values, which is like this. That's the same thing as saying this. And so our x is going to be, we multiply out to here and here. So this is -3, this is 3. And x is stuck in between them. So we have found our interval of convergence, which is from -3 to 3. If they were to ask you the radius of convergence, you would say it's 3. So yeah, that's it.